All right, this is section 4.5 of your textbook, page 239. We're solving a linear system graphically. Okay, a couple definitions we'll get out of the way. There's a system of linear equations. Basically, it's two or more equations using the same variables. Okay, that's all it is. So official definitions, a set of equations, at least two, that represent linear relations between the same two variables. So, very similar, two equations. On a graph, we would think of it as two lines. Table of values, two separate table of values. Okay? Point of intersection, it's the point that's common between the two lines. These two are pretty much the same thing. Solution to a system of linear equation. It's the ordered pair that solves the system of linear equations. It's the same thing as the point of intersection. Okay, so a little bit confusing. The textbook decides to define these separately. They're basically the same thing. The point of intersection, it's the solution for the two equations. Why is it the solution? Because when I substitute this x value in for x, I'm going to get the same y value. Okay? And thinking of it on a graph, it's the point where the two lines intersect. Okay, where the two x and y values are the same. Okay, so these two definitions for these two scenarios. Okay, in this case I use y for my total cost. So for sharing, it's going to be that fixed value of 5 plus my $2.50 per song, where x is my number of songs. Okay, similarly for files RS, there's no fixed value, so there's no constant, but there is the $3 times the number of songs. Daniel.
So just by looking at that, you already know share it's going to be better in, like, if you have more songs.
Share it's going to be better if you have more songs?
Yeah.
Yeah, you're right. After a certain point, right? But if you have two songs, right, you might say that files RS is better because it only costs $6, right? Two songs, $6. Two songs here would be 5 plus 5, so it'd be $10. Okay, but you're right, yeah, already just by looking at it, if you have lots of songs, like 10 songs for instance, 10 or more, easily files RS is going to be worse. Sure, it's going to be better. Okay, so that's the idea. I'm glad you were able to estimate that, but we're going to graph these two lines now. But the first thing I need to know before I graph this is what is the slope and what is the y-intercept? The nice thing about these two equations is they're already set up for us, how we like to see them. Michael, what's the slope for the first one?
2.5x.
Excellent. Not x, you don't need the x, it's just 2.5. Okay? And remember what that 2.5 represents, it's rise over run. And what's the y-intercept for share it? Michael?
5.
5. And for files RS, Joseph?
On the y-intercept.
The slope.
Oh, 3x.
Not x, just 3. And Matthew, the y-intercept? For files RS, for this equation, what's the y-intercept? Right?
Why?
Y? No? Doesn't make sense?
No, I think it's actually why.
You're asking me why?
No, no.
Yeah.
0.
0. You understand that, Matthew? Alright, so with this information, with the slope and the y, I should be able to graph it. So if you can come over here, Daniel. So the first equation, we're going to write them up here. So share it. Slope is 2.5. And y-intercept is 5. And the other equation, which is files RS, alright, so graphing share it first. The first point I'm going to graph is y is 5. 1, 2, 3, 4, 5. That's my y-intercept. And then I'm going to graph a slope of 2.5. So what that means is for every 1 that I run, I'm going to rise 2.5. So run 1, rise 1, 2.5. Run 1, rise a half, 1, 2. Okay. And I can do the same thing here. 1, 2.5. Half, 1, 2. So I get this line. Don't forget these arrows. On your last test, I didn't take off any marks for not putting the arrows, but I will in future tests. It needs to be there, okay? It's a very different graph if you don't include those arrows. For files RS, I know my y-intercept is 0, so I'm going to start with that point. And then I know my rise over run is 3, or my slope is 3, so I'm going to run 1 and rise 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Alright, we got a problem here. Yeah?
Sir, let's say you're just starting the graph at 0, 0, and it's not a Cartesian. Do you still need the arrow on 0?
If you're starting it here, ask me that again, sorry?
If you're starting from there and it's not a Cartesian grid,
It's always a Cartesian, why wouldn't it be?
But I mean, if there's no negative numbers, then just keep it positive.
Always.
Some of the homework we just have to do like a regular graph.
Oh, and a regular bar graph.
No, always do Cartesian now, you're in high school. Okay? Even if you use the first quadrant, always do Cartesian. Okay? Never know if there's going to be another function that goes into negative. Okay, the issue we have here is that my graph's not big enough to see where these two lines intersect. So what I may want to do is redraw this, just so that we have some more space. Alright, let's do that.
Sure.
Yeah?
I think it'd be easier to see that if you did the thing down the grid behind it.
It's okay, we're gonna make do. Okay, let's try this again. So the first one has a y-intercept of 5, 1, 2, 3, 4, 5, and a slope of 2.5, 1, 2.5. Hopefully that's enough distance to cross. And the next one has a y-intercept of 0 and a slope of 3. Very close.
So I don't think the camera's gonna be able to see that.
It's okay.
We're gonna redraw it soon.
No. Alright. I'm going to solve it algebraically to show you where it'll match. Okay? Just to, alright. Okay, so we graph it. Unfortunately, again, my 2.5 minus 3x is negative 0.5x. Now I'm going to divide both sides by negative 0.5. X is equal to 10. Okay. So these lines actually kind of take a while to actually cross. So they actually don't cross until 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They cross over here. Okay, so if you were to follow these lines up, they get really, really close, but they don't actually intersect until x equals 10. So even if I started at the very bottom here, I would have also ran out of room. Okay, so good thing I didn't redraw it again. Any questions about how I solved it using algebra? All right, because that's the preferred method, but you should also know how to graph them and find out the equation that way. Michael?
When you're finding the slope and it's just one number, like for example 3, you always have to rise at least 1?
Yeah,
Or
the number 3 in fraction terms is 3 over 1, right?
Okay, so you go up 3 and 1 to the right.
Yes, exactly.
To one side and then.
Exactly, yep. And so x equals 10, if I wanted to know what the solution now to this set of equations is, this is not quite the solution, it's half the solution. Joseph, can you tell us how we can find the point of intersection, so the point in common between the two lines? How can we find that?
Go to 10 on the x-axis,
Okay, yeah.
and then go all the way up.
All the way up, okay, and then you could see the point where they actually intersect. How can I do it algebraically?
Substitute the x used for 10.
Excellent, good, yeah. So if I take this value of x equals 10, and what you'll notice is it doesn't matter which one I plug it into, I'm going to get the same value. How do I know that? Because I'm the one who decided to set them equal to each other at the beginning. So here, let's try. On the first equation, 5 plus 2.5 times 10. So I'm subbing in x equals 10 into here. So what I end up with is 5 plus 25, I get 30. For my other equation, y equals 3x, 3 times 10, I get 30. Okay? So it doesn't matter which one I sub it into, I'm still going to get y equals 30. So therefore, the solution then, or the point of intersection, is what, Matthew?
30. Oh no, 10. 10
No?
and 30.
Sorry?
10 and 30.
Right, so the point of intersection is 10, 30. Now, Austin, what is the solution to the system of the linear equations? Sorry? Yeah, 1030. Yeah, I was trying to trick him there, but no, it's the exact same thing. Okay? It's the exact same thing. The solution to the equations and the point of intersection, which I said at the beginning, is the same thing. Okay? So, my point of intersection between these two lines is 1030. My solution to the equation is also 1030. X equals 10, y is 30. Any questions with that example? Yeah.
Didn't we already, is this almost the same thing we did earlier this week?
All similar. Yeah, you're right. Anybody, any other questions? Okay, let's try and go through the other examples a little quicker. Example 2, it says, what is the point of intersection of the graphs? So, the long way, okay, the long way is to graph these two, right? And to find out where they intersect, okay? So, you can do that in several ways, right? One way is you can make a table of values. You can plug in x values and find out the y values, and then graph those points. The way I like to graph is I like to rearrange the equation into this format first. Y equals mx plus b. Because that'll tell me the slope and the y-intercept, and that allows me to graph much quicker. So let's go ahead and do that. So I have 3x plus 2y is equal to 12. I want y on the left-hand side, so I leave the 2y over here. And then 3 I'm going to move over, so negative 3x plus 12. And now I'm going to divide everything by 2, so y can be on its own. Negative 3 over 2 plus 6. Okay, so there's my equation for the first line. My equation for the second line, look at that, it's already set up for us. Okay? What do we notice about these two lines? Who can tell me? There should be a bit of a red flag here. No.
The slope is the same.
The slope's the same. Yeah, very good. The slope is negative 3/2. What does a negative slope look like, Carlson?
You're rising, or you're going down for the rise, so it's going -3.
Yeah, so it looks like, I just wanted to get a general look. It's looking like that, right? It's moving down. Good. What does it mean if the two slopes are the same? Lee? Yeah, they never cross. And the reason why is because the slope, like we know of the word of slope, the angle of that line is the same. So if we were to graph this equation and this equation, they have different y-intercepts, 6 and 2. Okay, so one of them starts up here, and one of them starts down here, +2, there. Okay, but their slope is the same. Their slope, for every 2 that they run, so 1, 2, they go down 3. 1, 2, 3. This guy, 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. So we have this line and this line. Okay? So there's our graph of the two lines. Okay? So what we notice then is what? What's the solution, Josh?
No solution.
Right, exactly. Very good. There's no solution. There's no point of intersection. So for this question, no point of intersection, which is the same thing as saying no solution. Okay, any questions with that? Noah?
Would you put a question on the test that has no point of intersection?
Sure, of course.
Why?
Any other questions? All right, next example. So we took a bit of a shortcut there. We found out what the slope was in the y-intercept and we graphed them that way instead of doing table of values. You could, of course, have done a table of values. You should have drawn the same conclusions, that they never meet. Next one, determine the solution. So again, we have two equations here. One is already set up, y equals mx plus b. Let's rearrange this one so that it's set up that way. So 3x minus y is equal to 5. I'm just going to put the y over to the other side in this case, just because it's one step. So y is equal to 3x minus 5. Moving that y over. Okay, hope I didn't confuse anyone with that maneuver. So we have this equation and this equation. What do we notice again? Daniel?
They have the same slope.
They have the same slope. What are the solutions?
No solution.
No solution. Right? This one, no solution. All right. This one, let's hope there's a solution. So we're going to rearrange this one. It's going to be y equals x minus 2.
Wouldn't it be
Plus 2.
No, minus 2. Do a bit of work in your head, you'll get there, okay? Next one, this is going to be y equals 2 divided by 2 is x, minus 4 divided by 2 is minus 2.
so?
Isn't it the same?
What's that?
So won't they always?
So these two lines, if I were to graph this now, my y-intercept is negative 2, 1, 2 is there, and my slope is 1, rise 1, run 1, rise 1, run 1. I have this slope now.
They
For
all,
both of them though, right?
That's my line. My other line is identical. So my other line is right on top.
still no solution.
So what's the solution for this?
That they meet up in
They meet
at
over.
negative 2.
Where do these two lines intersect?
Oh, they don't.
There definitely is a solution, yeah?
They intersect at the start.
No? Where?
Of the y-intercept?
No. Yeah.
The x-intercept?
No. And the intercept. Michael.
From the start,
No.
I said that.
No. Carlson?
I was gonna say.
No other solution. No.
They're equivalent?
They are equivalent. They're the same.
-2.
No. Michael.
Everywhere.
That's right.
Oh! Oh!
So there's it for this particular equation. They intersect at every point. So the answer would be that there's an infinite number of solutions. Okay. Yeah.
Just make sure y equals 3x minus 3x minus y equals 5.
So, sir,
Yeah.
Should the answer be y equals 3x plus 5?
No. Because the 5's got to come over here and the y goes over there. So guys, if you're graphing two lines that are the same, they're identical, that means that there's an infinite number of solutions. Remember, the solution is where one x value subbed into both equations gives the same y value. If I choose any value of x and I sub it into both these equations, because the equations are the same, I'm going to get the y value. So in this case, any value gives us the solution. Matthew.
we can answer that using algebra.
I've already done it here. The equations are the same. So it's already done. Yeah?
Infinite solution.
I would say that because the two equations are the same, they're the same line, there's an infinite number of solutions. The way the book words it, there is an infinite number of solutions for this system of linear equations.
Do we draw it or do we like do the infinity sign? Or do we write out?
No, you just write it.
But can we draw the?
You can't. All right, last one, guys. Example number 5. It says find two numbers where the sum of both numbers divided by 4 is 3. Okay, so we're looking at this question here now. So we can put that in brackets, is equal to 3. And 2 times the difference of the two numbers is negative 36. So 2 multiplied by the difference, which is x minus y, is equal to negative 36. All right, so there are two equations. Now it wants us to find the solution to those two equations. All right, so who can tell me the first step? What will we take to do this? Yeah, Josh.
We isolate y. So it would be like y.
Good. So the first step, if we're graphing, we want to get it into this format, right? Y equals mx plus b. So let's do that for the first equation here. We have x plus y over 4 is equal to 3. So an easy way to do this is I multiply both sides by 4. That will get rid of that number. So these cross out, so I get x plus y is equal to 12. Next step, y is equal to, moving the x in front there, negative x plus 12. Okay, so there's one of my equations of a line. For the second one here, I'm going to divide both sides by 2. So I can get x minus y on one side is equal to negative 18. Any questions that what I did there? Michael?
The first one, does the x always have to be in front of the numbers? Like,
Here? Yeah, that's the, yeah, I put the x in front on purpose because that's the format we want. Okay? Next one here, so now I have negative y is equal to negative 18 minus x, so the x is coming over. Dividing everything by negative 1, so I'm just changing the signs. I've just moved the x in front, it was positive, I moved it in front. And the 18 also changes. Alright? So finally we get two lines where the slope, be careful here, the slope is not the same. Okay, one is going like this, negative 1, and one is going positive 1. So these two definitely should intersect. Okay? So if we were to graph them, to find the point of intersection. Remember this section in the book is finding the solution using graphing. The first one is going to be up at 18. 1, 2, 3, 4, 5, 6. Let's say somewhere up here. So positive 18, that's my y-intercept. And I'm going down 1 to be positive.
To get 18.
Oh, to get rid of this 2.
Oh, okay.
Okay? Alright, so there I can see if you graph this accurately, you'd have the solution there. You find out what that point is. I'm a little lazy with the graphing, so I'm going to figure it out algebraically. The way I do that is I set the y values equal. So I'll have negative x plus 12 is equal to x plus 18. So again, setting these two equations equal, now I'm going to solve for x. So I get negative 2x is equal to 18 minus 12. X is going to be equal to, this is 6 divided by 2. Okay? Which lines up pretty close to what I have on my graph. Alright, and if you were to graph accurately, it would be exactly. Now, the last part of this problem is to just find out what the y value would be. So I take this negative 3 and I sub it into either one. Let's sub it into this one. Y is equal to negative 3 plus 18.
Y equals 15.
Y is 15. So therefore, my point of intersection in my solution to this equation would be negative 315, which corresponds nicely with my graph. Okay? Questions?
Now,
Yeah.
can we be lazy with the graph?
No. You can be lazy. I mean, you can show a graph like this if you want in your homework. So a rough graph, if you prove it algebraically. Okay, and then show on the graph, point to it and say this is negative 315. Okay, but if it's a test and there's a graph on the test, you're going to get marked on that graph, so you don't want to be lazy. Alright, that's the end of the lesson.
Sir, our quiz.
Got it.